Greetings, mathematicians. We have this problem. Solve and graph the following inequality. X plus 5 all over 6 is less than 4. So we need to go ahead and solve it, and then we need to go ahead and graph that as well. So I see we need to isolate the variable x. So I'm going to go ahead and multiply both sides by 6 to get rid of that denominator. So I multiply by 6 here, and then I also multiply by 6 on the other side as well. So the 6's cancel out, and then I'm left with this numerator right here. So we have x plus 5 is less than 24. Okay. Now it's just a one-step inequality. I need to go ahead and subtract 5 from both sides. And then I'm left with this answer. So we have x is less than 19. Now this is a solved inequality, and then we need to go ahead and graph it as well. So I like to put 5 numbers on a number line. I'm going to put 19 in the middle. And then we have the inequality x is less than 19, so that means that we are going to have an open circle. And we want all the numbers less than 19, meaning that we head to the left. And that is our final answer. All right, so we are in Learning Target 16, Compound Inequalities. Our essential questions: how can I solve compound inequalities? How can I graph compound inequalities? And how can I write compound inequalities when given a graph? So here's some vocab. So a compound inequality is two inequalities connected by and or the word or. So we have this example here. 7 is less than x is less than 9. So that is technically an and statement. This is equivalent to this saying right here. So if we have this phrase, x is greater than 7 and x is less than 9. Both of these inequalities, this one right here and this one over here, they are equivalent statements, right? Because x, in this case, it has to be bigger than 7, but it has to be less than 9. Same thing here. X is bigger than 7, but it's less than 9. So that is an and statement. We also have or statements, right? So either one of these can be true, right? So x is less than 7 or x is greater than 9. Okay, example 1. Graph all real numbers that are greater than 0 and less than or equal to 4. So I'm going to go ahead and write it so that we see it in terms of a variable. So all real numbers, that is just x. We want all real numbers that are greater than 0 and less than or equal to 4. So we can go ahead and write x is greater than 0 and x is less than or equal to 4. So x is less than or equal to 4. So we can write it this way, or if you prefer writing it in just one line, we can write it like this. So we have 0 is less than, x is less than or equal to 4. Either case that you write it, it looks good to me. Now we just need to go ahead and show that on a number line. So I'm going to go ahead and put some numbers. So we have 0 is here. 1, 2, 3, 4, 5. So we have -1. When starting out, I like to put the numbers down here. And then we need to go ahead and identify what direction are we going. So we want all the numbers that are bigger than 0, not including 0, so we have an open circle. So we're heading in this direction here. And then we want all the numbers that are less than or equal to 4. So that's going to be a closed circle. And this time we're heading to the middle. So we go in this direction right here. So our final answer, any number that is within this region right here, that satisfies that inequality, right? Because if I take the example, if I take the number 2, that satisfies this statement right here. It is a number that's bigger than 0, but it's also less than or equal to 4. Okay, let's look at that next example. So we want to graph all real numbers that are less than -1 or greater than 2. Okay, so again, I'm just going to go ahead and write it into a mathematical statement. So all real numbers, we're going to say x, okay, less than -1. So we have less than -1, or we need to include that word or, greater than 2. So x is greater than 2. Okay, and then same thing, let's go ahead and graph that. So I have -1, so I'm going to go ahead and put that here. And 0, 1, 2, 3. So I have -2. Okay, and this is an or statement, meaning that it only needs to satisfy one or the other of these statements. So we have x is less than -1, so that is an open circle, and we are heading to the left. Or x can be greater than 2. So we're going to do an open circle again, this time heading to the right. Go ahead, pause the video, try this example out. We're going to work through the solution together, and then you can skip through and check your answer. So all real numbers that are greater than or equal to -2 and less than 3. So again, I'm going to go ahead and write that out. So we have greater than or equal to -2. So we have -2. Less than or equal to x, less than 3. Right? That's one way that we can write it, or you can also write it this way. So we have x is greater than or equal to -2, and x is less than 3. Okay? Make your number line. We'll put -2. Okay? So we have that number line. So x is greater than or equal to -2. So that is going to be a closed circle. And we're heading to the right. And we go all the way up to 3. And we have an open circle there. So any number that's within that region is a solution to that inequality. Okay, so let's go ahead and graph the second one. All real numbers that are less than or equal to -3 or greater than 0. So we have x is less than or equal to -3. So x is less than or equal to -3 or greater than 0. X is greater than 0. Okay. So again, we're going to go graph. So we have x is less than or equal to -3, so a closed circle. And we're going to the left. And then we have x is greater than 0, so an open circle, and we're heading to the right.